Okay, as we look at our first problem on our Chapter 5 review, number 1 says factor the expression and use the fundamental identities to simplify. So we've got the cosine squared of x, secant squared of x minus the cosine squared of x. So our very first step here is we want to go ahead and factor it. So you're going to notice we do have a common cosine squared of x in both of our terms here. So I'm going to go ahead and factor that out. So you're going to notice I factored out front. And then when I factor it out of this, I'm just left with the secant squared of x. And when I factor it out of this other side, I'm left with minus 1. So when I'm done factoring this, I got the cosine squared of x times the secant squared of x minus 1. So next thing I need to do is I need to go ahead and see if I can find a fundamental identity, a Pythagorean identity that matches the secant squared of x minus 1. So you take your formula sheet and look at our formula sheet right here. And notice that I do have this Pythagorean identity that just says the secant squared of u minus 1 equals the tangent squared of u. So that's going to be my next step. I'm going to go ahead and replace that secant squared of u minus 1 with the tangent squared of u. So going back to our problem. So back here on our problem it says that we have the secant squared of x minus 1. According to our formula sheet, that is equal to the tangent squared of x. So I go ahead and replace that. So now that I've got the cosine squared of x times the tangent squared of x, again, if you need to, you can go back to your formula sheet and change the tangent squared of x. So if you look at your formula sheet right here, the tangent squared of x is equal to the sine all over the cosine. So using that identity, I can go ahead and change this. So that changes to the tangent is now going to become sine squared over cosine squared. So changing that to sine squared over cosine squared. Now the cosine squared is going to cross out, and my answer is going to be sine squared of x. So the answer number 1 is going to be the sine squared of x. Going on to the next problem, on number 2, it says we have the secant of x plus the cosecant of x all over 1 plus the tangent of x. So on this problem right here, the very first thing you want to do is you're going to want to get a common denominator. Or so you're going to want to change your secant of x and your cosecant of x. Both of them we're going to change to 1 over the cosine. So if you look at your sheet again, you can see on your sheet that those are the reciprocal identities. So if you look at your sheet right here, you go to your formula sheet, and here's your reciprocal identities. So here's the reciprocal identities that says we have. Let me scroll down to it. So make sure you're kind of familiar with your reciprocal identities. You're going to change all those problems in there to their reciprocal identity. So changing that to their reciprocal identities. So the secant of x, we'll go ahead and change it to its reciprocal, which is 1 over the cosine of x. Cosecant of x, its reciprocal identity is 1 over sine of x. And then notice, again, I change this denominator here. So in your denominator, that tangent of x, I'm going to change that to the sine all over the cosine. Okay, now that I've done that, I've changed those, I need a common denominator. So to find my common denominator, so here's this cosine of x, sine of x, so its common denominator would be cosine of x, sine of x. And then also down here, I'm going to treat these separately. This is over 1, so this one would actually have a common denominator of the cosine of x. So that's going to be my next step, is to get those common denominators. So to get the common denominator on this problem right here, so I'll go ahead and scroll down to it. You're going to see that my common denominator is sine of x, cosine of x. So that means that I'm going to have to multiply this right here, and multiply this one by the sine of x. And I'm going to multiply the denominator by the sine of x. I'm going to multiply this one by the cosine of x, and also by the cosine of x. And then down here, this is 1 over 1. I'm going to multiply both top and bottom by the cosine of x. So when I do that, you'll notice when I scroll on down to it, you're going to notice that when I multiply those together, so when I take that 1 times my sine of x, I get sine of x. When I take this times the cosine of x, I get cosine of x. So I'm going to add my numerator, keep the same denominator. So sine of x plus cosine of x all over sine of x, cosine of x. And same thing with the other one. I add my numerator, that's the sine of x plus cosine of x all over cosine of x. So remember my laws of fractions. So I have to flip this bottom fraction right here and multiply. So I'm going to flip this, and I'm going to multiply it. So notice right over here, here I flipped it. So that becomes a cosine of x all over sine of x plus cosine of x. So you're going to notice that when I do that, these are exactly like, so I can cross them out. The cosines of x crosses out, and I'm just going to be left with 1 over the sine of x. Now going back to my reciprocal identities, I know that 1 over the sine of x, when I go ahead and take its reciprocal, that's going to become the cosecant of x. On this next problem, on number 3, directions say convert all the terms to sines and cosines and simplify to find the expression that completes the identity. We've got the secant of x, all of the tangent of x, times the cosecant of x. So again, if you look at your formula sheet, here's all your reciprocals in terms of sines and cosines. So this is what I'm looking at right here. So that's what I'm going to use to convert all those to sines and cosines. So on my problem, when I get back to it, it says that we have the secant of x. So the secant of x, I'm going to convert that over to 1 over the cosine of x. Now the tangent of x, I'm going to convert that to sine over cosine. And the cosecant of x, I'm going to convert that to 1 over sine. So now we'll go ahead and scroll on down here. And now I've got 1 over the cosine of x, all over the sine of x, cosine of x, times 1 over the sine of x. So you notice that since this is multiplication, I can cross these out. And so that's just going to be 1 over the cosine of x, all over 1 over the cosine of x. Now flip and multiply, or just cancel them out. And I know that that answer is going to be 1. So flip and multiply, the cosines cross out, and your answer just becomes 1. On problem number 4, problem number 4 says we've got cosine squared of x times 1 minus sine of x. We just want to simplify this. So the first thing I'm going to do is I'm going to go to my chart. Here's my trig formula sheet. And it says that, in this case right here, that the cosine squared of x is going to equal 1 minus the sine squared. So that's going to be my first step. I'm going to go ahead and change that over. So coming back to our problem, I'm going to change that cosine squared of x to 1 minus sine squared of x. So this right here becomes 1 minus sine squared of x. Okay, now that I've done that, I'm going to go ahead and factor that. So factoring 1 minus sine squared of x. So remember, this is the same type of problem as 1 minus x squared. That would be its algebraic equivalent, which factors to 1 minus x times 1 plus x. You can use that same pattern to go ahead and factor 1 minus sine squared of x is going to factor to 1 plus the sine of x times 1 minus the sine of x. Now that I've done that, the 1 minus sine of x, those are the exact same thing. I'm going to go ahead and cross those out. And I'm going to be left with my answer of 1 plus the sine of x. Let's take a look at number 5. So number 5, it says verify the identity. So in this case, we know we're just going to work with this left-hand side. We've got to show that it equals the right-hand side. So we're just going to work with this. So remember, when we're verifying identities, they already give us the answer. The answer to this is the cosine of x. We've got to go ahead and show that that's what it equals. Whenever I see something being squared like this, I'm always thinking Pythagorean identity. I'm going to go ahead and go to my formula sheet and see if I can find that Pythagorean identity. So on my formula sheet right here, I look at it, and I'm looking for the cosecant squared of x minus cotangent squared of x. I find that identity right here. It says that that is equal to 1. So now I can go ahead and go back to my problem. And I can replace that with a 1. So notice right here, I go and mention that fact. It's a Pythagorean identity. So here's my Pythagorean identity right here. That just becomes 1. So now I'm just left with my equation, 1 over the secant of x. And 1 over the secant of x, if you look back on your formula sheet, so 1 over the secant of x is equal to the cosine. So that's my next step. Using that reciprocal identity, I'm just going to go ahead and change that to the cosine when I flip it up top. And so there's my proof that the cosecant squared of x minus cotangent squared of x divided by the secant of x all equals the cosine of x. On number 6, I've got 4 cosecant of x plus 6 all equals 7 cosecant of x. It just says solve the equation. So to solve the equation, we've got to combine like terms. So to combine like terms, the very first thing I do is I'm going to combine my cosecants together. So I'm going to subtract 4 cosecant of x from both sides. And when I do that, I'm going to be left with 6 all equals 3 cosecant of x, because 7 minus 4 is going to be 3. Now that I've done that, continuing my solving of my equations, I'm going to divide both sides by 3. So notice when I divide both sides by 3, that's going to just leave me with the cosecant of x. So when I divide both sides by 3, I get 2 equals the cosecant of x. Well, the cosecant of x is not on my chart. And it says right here to solve this equation. So I'm going to find my answer on my chart. So notice I'm going to reciprocate both sides of the equation. So in other words, I take the reciprocal of 2, gives me 1/2. The reciprocal of the cosecant of x is the sine of x. Now I need to get x by itself. So I go ahead and take the arc sine of both sides. That's the opposite of the sine. So I get the arc sine of the sine of x all equals the arc sine of 1/2. And so now I get x is going to equal the arc sine of 1/2. Okay, now I got to find my answer to this, and it's on my chart. So I go to my chart. So here's your trig chart right here. And I'm going to go where the sine is equal to 1/2. So I'm looking for the arc sine of 1/2. So that means what angle has a y-coordinate of 1/2. So that answer is pi over 6. So that's how I get my first answer. So if I go back to my assignment right here, you're going to notice here's my first answer of pi over 6. Now remember, that's not the only place that the arc sine is equal to 1/2. Because if you look at your other quadrant chart, you're going to notice that sine is also positive in the second quadrant. So I need both the first quadrant answer, which is what I got, which was pi over 6. But now I need a second quadrant answer. So this is my guide. Remember, for the second quadrant, I got to take pi minus that. So I take pi minus pi over 6 to get my second angle answer. So I got 6 pi over 6 minus pi over 6, which gives me my second answer of 5 pi over 6. So there's my second answer. So now going back to my review. So here's my second answer of 5 pi over 6. So here's my two answers. So that's one rotation. If I look at the directions, it says to solve the equation, so it wants all answers. So remember, to account for all rotations, just write the plus 2 pi in after your answer. So pi over 6 plus 2 pi in, and then 5 pi over 6 plus 2 pi in. On number 7, it says we have 2 cosine of x. Sine of x equals the sine of x. So first step, you're going to notice on number 7 it says it wants to find all the solutions of the equation, the interval from 0 to 2 pi. So first thing I want to do is I want to move the sine of x over to the other side so I can go ahead and factor it. So I'm going to move it over here. So when I do that, I get 2 cosine of x, sine of x minus sine of x equals 0. Now I notice that in my two terms here, so here's my two terms right there, there's a common sine of x that I'm going to take out. So I take the sine of x out, and when I do that, I'm left with 2 cosine of x. And when I take it out of this side, I'm going to be left with minus 1. So now solving equations, I take each factor. Once I'm done factoring, I take each factor and set it equal to 0 and solve them individually. So I got sine of x equals 0. And then I also have the 2 cosine of x minus 1 also equals 0. So now solving each one of these factors separately, I'll go ahead and scroll it on up here. So notice the sine of x equals 0. Solving that, I take the arc sine of both sides, that crosses out, and so I'm left with this statement right here, x equals the arc sine of 0. So I'm going to go to my chart and find it here in just a second. But first, let's go ahead and solve this one. So I got 2 cosine of x minus 1 equals 0. So I'm going to add 1 to both sides. And then I'm going to divide by 2. So I get the cosine of x equals 1/2. So I arc cosine both sides. And when I do that, I get x equals the arc cosine of 1/2. So those are the two answers that I'm looking for on my chart. I'm looking for the arc sine of 0. I'm also looking for the arc cosine of 1/2. So I'm going to go to my chart. So the first one I want to find is the arc sine of 0. So what angle has an x coordinate of 0? Here's my 0. The angle that has the x coordinate of 0 is going to be 0. So that's my answer for that equation. And then also the cosine of 1/2. The arc cosine of 1/2. The angle that gives me 1/2 for my x coordinate is going to be pi over 3. So now that I have my two answers, you're going to notice that I've listed both those answers right here on my solution. So I've got this first answer right here, which is 0. And then let me go ahead and scroll this other one up a little bit. So this other answer, which is pi over 3. So here's my two main answers. Okay, now I go to my quadrant chart to see what the other answer is going to be. So on my quadrant chart, I notice that sine is positive in both these quadrants right here. So here's this right here. So my first answer was a 0. And notice that is a quadrantal. It just happens to be that way. So to get the other answer, I'm going to take pi minus 0, or I can take pi plus 0, either one. And so that answer is going to be pi. So there's my two answers off of that. And my other answer that I got was pi over 3. So here's pi over 3. That was the cosine answer. So cosine is positive here, and it's also positive here. So here's my guideline how to put it there. So I'm going to take 2 pi minus pi over 3. So that's going to be 6 pi over 3 minus pi over 3. That's going to give me my second answer, which is 5 pi over 3. So there's my two answers. So now that I have my two answers for both those equations, I'll go back to my review solutions. And you're going to notice here's all of my answers. So pi over 3, 5 pi over 3, and 0 pi. Now, if you look at your Chapter 5 review, it says find all the solutions in the interval, and then it has this little 0 to 2 pi by it. Now when it says 0 to 2 pi, that means it only wants one rotation. So that's why I don't write the plus 2 pi in next to those answers, because this right here is part of my directions. So 0 to 2 pi. So those will be my 4 answers, and that's what I'd leave it at. Okay, number 8. It says I've got the sine of 3x all equals the square root of 3 over 2. So again, the directions say find all solutions of the equation. So find all solutions of this equation. Notice I arc sine both sides, so that'll cross out. And I'm left with 3x all equals the arc sine of the square root of 3 over 2. Now before I divide by 3, I need to find this answer right here of the arc sine of the square root of 3 over 2. So that means I'm going to have to go to my chart and find that answer. So going to my chart, let's see, on my chart it says that I have, and let me scroll this back down a little bit. So here is my square root of 3 over 2. So what angle gives me that answer, which is pi over 3. So pi over 3 would be my one answer. And sine, if you look at your quadrants, is also positive in the second quadrant. So we just found our answer of pi over 3 in my first quadrant. So I'm going to take pi minus this to find my second answer. So pi minus pi over 3. So that's going to give me 3 pi over 3 minus pi over 3, which is going to give me that 2 pi over 3. So there's my two answers right there. Pi over 3 and 2 pi over 3. So I'm going to go back to my solution guide here. And you're going to notice here's my two answers. I've got pi over 3 and 2 pi over 3. Now if you look at the directions, there's nothing that says it just wants one rotation, so that's why you write the plus 2 pi in after it. And then when you're done writing that, now I'm going to divide everything by 3. So you're going to see how this kind of changes our answer just a little bit. So you're going to notice when I divide this by 3, I have to divide all the terms by 3. So dividing everything by 3, so when I flip and multiply, so pi over 3, when I flip and multiply, it becomes this pi over 9. And notice I still have my plus 2 pi n, all divided by 3, and 2 pi over 9 plus 2 pi n divided by 3. And that would be your answer. Okay, number 9. Number 9 says it wants us to find the exact value of this. So anytime that I see that word exact value, that means I'm going to have to get it off my chart. So cosine of 105, I'm going to go ahead and change that to 45 plus 60 because 45 and 60 are on my chart. Now following your formula, remember, you cannot distribute that cosine across angles. You have to follow your formula sheet. So if you look at your formula sheet right here, we'll go ahead and find that formula on our formula sheet. So right here is our sum and difference formulas. And those sum and difference formulas, I notice here is the cosine of u plus v. That's the formula that I'm going to follow. And apply that to my 45 plus 60. So using that formula, I'm going to go back to my review here. And so now notice that this is the cosine of 45, cosine of 60, and then the formula says there's a subtraction sign there, and it's the sine of 45, sine of 60. So now that I've separated that out, I can go back to my formula sheet right here and find all those answers. So here's my trig chart. So notice I had the cosine of 45. So here's the cosine of 45, which is square root of 2 over 2. Then I had the cosine of 60. So here's the cosine of 60, which is 1/2. And then I also had the sine of 45, which is square root of 2 over 2. And then I have the sine of 60, which is the square root of 3 over 2. So those are all my answers. I'm going to substitute them in. So here are my review solutions. So notice again, cosine of 45, square root of 2 over 2. Cosine of 60 was 1/2. Sine of 45 is square root of 2 over 2. Sine of 60 is the square root of 3 over 2. So now following my laws of fractions, I'm going to multiply those together. So remember, you multiply numerator by numerator, so that gives us the square root of 2. So the square root of 2 times 1 is going to be the square root of 2. 2 times 2 is going to be 4. I still have my subtraction. I got the square root of 2 times the square root of 3, which is going to be the square root of 6, all over 2 times 2, which is 4. Now I'm going to add my numerator and keep the same denominator. So when I add my numerator, I get the square root of 2 minus the square root of 6. Keeping that same denominator, that answer is 4. On this next problem, it says that on number 10, it says it wants you to verify the identity. So to verify this identity, we're going to work with the left-hand side, show that it equals the right-hand side. To do that, you're just going to use your sum and difference formulas. Remember, you can't distribute across an angle, so you can't distribute with your trig. So again, we're going to use our formula. So again, if you want to take a look at your formula, it was this sum and difference formula. And in this case, I think it was the cosine of u plus v. So we're going to use the cosine of u plus v. We have x minus pi over 2 inside of our equation here. So in our problem, we're just going to apply that formula to this. So you'll notice we take the cosine of the first angle. That's cosine of x. And cosine of this angle, cosine of pi over 2. So just following your formula. Then notice this minus. If you look closely at your formula, that is a plus. Sine of the first angle times the sine of the second angle. So now that you've done that, cosine of x stays the same. So you've got to find the value of the cosine of pi over 2. We'll find that here in just a second. Sine of x stays the same. And we'll find the value of the sine of pi over 2 at the exact same time that we're finding those other values. So if you go to your trig chart, so pi over 2, so you're going to notice that the cosine of pi over 2, so here's pi over 2, the cosine of it is 0, and the sine of it is equal to 1. We're going to go ahead and substitute those in, and then simplify down our equation. So notice that this stayed the same, this became 0, this stayed the sine of x, and this becomes 1. So 0 times this crosses out. Sine of x times 1 is just going to give us the sine of x. Okay, on problem number 11, it says find the exact value of the tangent of 2x using the double angle formula. You have the tangent of x equals 7/11. You got pi is less than or equal to x, which is less than 3 pi over 2. So the first thing you want to do is you want to go find your tangent double angle formula. So in your trig formula sheet, so here's our double angles right here. So here's our tangent formula that we're going to be following. So we know that the tangent of 2u is equal to 2 tangent of u all over 1 minus tangent squared of u. So that would be the very first thing that you want to do, is you just want to go ahead and write that down. So notice I've written that down. So here's my formula, 2 tangent of x minus all over 1 minus the tangent squared of x. So this tells me that the tangent of x equals 7/11. So that means I can just actually substitute this number into here and into there. And as I'm doing this, I have to keep in mind that here's my quadrant that I'm sitting in. So notice that this right here describes the third quadrant. So if you look at your quadrant chart, remember this is 0, this is pi, this is, or say pi over 2, this is pi, this is 3 pi over 2, and then a full rotation all the way around is 2 pi. So this says that x lies somewhere between pi and 3 pi over 2, so it's lying somewhere right in our third quadrant. And tangent in our third quadrant is positive. So notice it is positive, so I don't have to worry about positives or negatives. This is actually just a substitution problem. So let me go ahead and scroll on down here, and I'll show you how we substitute in that tangent of x equals 7/11. So here's tangent of x equals 7/11. Just substitute in right here and right here into your formula. So notice we're just taking the place of the tangent of x. Notice the tangent of x is completely gone. Now we just have to solve our remaining equation. So here I've got 2 times 7/11. So that's 2 over 1. So 2 times 7 is going to be 14. 1 times 11 is going to be 11. So that's my numerator, 14/11. Okay, now for the denominator, here I've got 7/11. And remember, that's being squared. So I've got to square that. So 7 squared is 49. 11 squared is 121. Okay, now that I've gone ahead and squared that, I've got to take 1 minus 49 over 121. So remember, this is a denominator of 1. So I'm going to multiply both top and bottom by 121. And that's going to give me 121 over 121 minus 49 over 21. So now I go ahead and simplify my denominator here. So 121 minus 49 is going to give me 72. And I keep the same denominator, which is 121. Okay, now my rule is flip and multiply. So that's what I'm doing. I'm going to flip this bottom one and multiply it. So when I do that, notice I can cross cancel. It makes it a little bit easier. So notice that 11 becomes a 1, and 121 is going to become 11. And then I can also reduce down my 1472. So I can cross cancel. This becomes a 7, and this is going to become a 36. So now I've divided both top and bottom by 2. So now I just take 7 times 11. I'm going to get 77. 1 times 36, I get 36. And that's going to be my answer. So here's my answer right here of 77, 36, using that double angle formula. Okay, on number 12. Number 12 says, I've got the cosine of 2 theta. And it says, use the figure to find the exact value of the trigonometric function, the cosine of 2 theta. So I'm going to notice that on my original equation, I've got a 12 and I've got a 16. Now, if you can reduce those down, make it a little bit easier, it's worth doing. So you're going to notice that both 4 can go into 12 and 16. So I can reduce this down to a 3 and a 4. So that makes it a little bit easier to work with my Pythagorean theorem. So using my Pythagorean theorem to find this side right here, I've got 3 squared plus 4 squared equals c squared. So 9 plus 16 equals c squared. So c squared equals 25. So c is going to equal 5. So that just found my other side for me. Now the reason why I had to find my other side is because you're going to notice the cosine of 2 theta, I have to use a double angle formula. It doesn't matter which one I use. There's 3 of them. So if you look at your chart, and if you look at your formula sheet, so I'm just going to go to our formula sheet, and you're going to see that there are 3 formulas I can choose from. It doesn't matter which one I choose. All 3 of them will give you the exact same answer. I just went ahead and decided to choose the 3rd one. So this is the one I'm going to use, is this one right here, 1 minus 2 sine squared of u. That's the formula I'm going to use to find the cosine of 2 theta. So if I go back to my equation here, so it doesn't matter which one I use. I'm going to say, okay, the cosine of 2 theta, I have to use my formula, which is 1 minus 2 sine squared of theta. Okay, so all I have to do is just have to remember SOHCAHTOA. So I've got the sine. So remember, sine is the opposite over the hypotenuse. So notice sine of theta is 3/5. So I'm just going to substitute that into my equation. And then it's just a matter of solving it. So you're going to notice you're using SOHCAHTOA, you're using your right triangle trigonometry, and then you're using your double angle formulas to find this answer. So substituting that in, now I'm going to solve it. So remember your order of operations, you've got to square this first. So 3 squared is going to be 9, 5 squared is 25. Now, following the order of operations, you're going to multiply this. So remember, this is 2 over 1. So now I'm just going to multiply numerator by numerator, denominator by denominator. So when I do that, so 2 times 9 is 18. 1 times 25 is 25. Okay, now I got to get my common denominator. So I got 25 25ths minus 18 25ths. So 25 minus 18 is going to give me the 7. Keep the same denominator, which is 25. So the answer to that would be 7 25ths. Okay, on number 13, it says use a double angle formula to rewrite the expression. So the thing we need to remember about our formulas is they work both ways. What I'm talking about is you can go from the left side to the right side, and you can also go from the right side to the left, or sorry, from the right to the left. So they work both ways. So when you get into calculus too, you have to kind of get used to the idea that sometimes you'll go one way and sometimes you go the other. So the first thing that I want to do is I want to look at number 13. It says I got 10 tangent of x all over 1 minus tangent squared of x. So it almost matches this one right here. The only difference is there's a 2 instead of a 10. So if I can get that changed to a 2, then I can use that formula and I can go the other direction with it. So let's take a look at our problem and see if I can get that changed so that it is a 2. So back here on my problems, I've got the 10 right here. And this 10 needs to be a 2. So I have to rewrite it to match it. So that's what I'm going to do. I'm going to rewrite this so that it matches my formula. So I know that instead of that being a 10 right there, I need it to be a 2 so it matches my equation. So to do that, I know that 5 times 2 will give me 10. So I'm just going to leave that 5 out front. And now that I've done that, you're going to notice that this entire thing right here matches my formula. So if I look back on my formula sheet right here, this is a perfect match, so now I can replace it with this. And so that's what I'm going to do. So I'm going to rewrite this so that it matches up. So back here on my solutions, so this entire thing right here matched up. So this 2 tangent of x, 1 minus tangent squared of x. Notice I wrote down, substitute in the tangent of 2x. So now I substitute that in, and I'm still left with my 5. So that would be my answer, 5 times the tangent of 2x. So it works both ways, going from the left to the right, and also from the right to the left. On number 14, the directions say find the exact value of the cosine of 15. So again, the key here is the word exact value. So that means that I'm going to have to find it off my chart. So I find 2 numbers on my chart that I add or subtract to give me 15, and that is 45 minus 30. So now that I've done that, I'm going to use my sum and difference formulas again. So going back to your sum and difference formulas, find the one that matches this cosine. So here's my sum and difference formulas. Let me scroll back to them. Here's the sum and difference formula right here. This is what I'm going to follow. So notice it's the cosine of u minus v all equals the cosine of u, cosine of v plus sine of u, sine of v. So now that I have that, I'm going to go ahead and separate that out. So remember, I can't distribute it, so this becomes a cosine of 45, cosine of 30. Just following your formula, you got plus. Now we got the sine of 45, sine of 30. Now that I have that, I just have to go ahead and use my chart to find those answers. So going to your chart to find those answers. So here's my trig chart. So notice my first one was the cosine of 45. So here's my cosine of 45 right here. Cosine of 30. And sine 45. And also sine 30. I'm going to use those numbers to substitute into my formulas right here. So back to your problem. So notice here's my cosine of 45 is the square root of 2 over 2. Cosine of 30 was square root of 3 over 2. Sine of 45, square root of 2 over 2. Sine of 30, 1/2. Okay, now I'm going to multiply square root of 3 times the square root of 2. It's going to give me the square root of 6. I got 2 times 2 is going to be 4. I still have my plus sign here. Now multiplying numerator by numerator. So the square root of 2 times 1 is going to be the square root of 2. 2 times 2 is going to be 4. Now I'm going to add my numerator, keep the same denominator. So my answer is going to be the square root of 6 plus the square root of 2 all over 4. And it looks like I wrote down the chart again. So here's the chart written down for you again if you need to use it. So there's your chart. On number 15, it says use the figure to find the exact value of the trigonometric function. So you need to recognize that this right here, this is a half angle. Can everybody see how that angle is being divided by 2? So once again, you're going to go find your half angle formula. So you go to your trig formula sheet. And on your trig formula sheet, it says right here is our half angle formulas. So the half angle formula that I want to use is this one right here. I got plus or minus the square root of 1 minus the cosine of u all over 2. So that's what I'm going to use. Is I'm going to use that half angle formula to find my answer. So if I look at my problem again, so here's the triangle that it gives us. And again, if you can simplify it down, it makes it that much easier. I noticed that both the original things was 21 and 28. I can divide that by 7. So that's going to reduce this down to 3 and 4. So once I've reduced it down to 3 and 4, use your Pythagorean theorem to figure out the rest of your triangle. So I got 4 squared plus 3 squared all equals c squared. So you got 16 plus 9 equals c squared. So 25 equals c squared. So c is going to equal 5. Now that I know that c equals 5, I can fill out my triangle right here. So this looks like it is a 3, 4, 5 triangle. Okay, so now I need to find the cosine of theta. So the cosine of theta, so working off my angle right here, theta, I know that cosine is adjacent all over hypotenuse. So that means it's equal to 4/5. So I can go ahead and substitute that into my formula. So I got the square root of 1 minus 4/5 all over 2. So now to solve that out, I just got to simplify that. So to simplify this, so notice I'm going to change this to 5/5 minus 4/5. So you can multiply by the LCD, or you can just go ahead and solve this out. So when I solve this out, I get the square root of 1/10. Rationalize it, and you get the square root of 10 over 10. So notice right here, I'll show you step by step how we got to the square root of 10 over 10. So right over here, when I have 1, the square root of 1 minus 4/5 all over 2. So that is the square root of 5/5 minus 4/5 all over 2. So that's going to be the square root of 1/5 over 2. You flip and multiply, and that's how you end up with the square root of 1/10. Now there is a shortcut that we sometimes use in calculus where we just multiply everything by the least common denominator, and I think we talked about that. So in other words, I just multiplied this first term by 5, this term by 5, and this term down here by 5. And that's how I got this right here. Either way works just fine. If you want to do it the longer way, write it out, do it the shorter way, then just simplify it down, you get the square root of 10 over 10. Okay, number 16 says use the law of sines to find the remaining sides and angles of your triangle. So you're going to notice that they give us these two angles of 40 and 12. So to find angle C, I'm just going to take 180 minus 40 minus 12, and I get 128 degrees for angle C. So now that you know that C is equal to 128, you can now set up your proportions. So notice here's my proportion. So I don't know side A. Its angle is the sine of 40, all equals 100 all of the sine of 12, which equals C all of the sine of 128. So now that you've set up your proportion, you can just take your calculator. Let's go ahead and figure that out. Now remember, if you can't remember the law of sines, it is on your formula sheet. So you're not expected to memorize it, but most students do have it memorized just because of how easy it is to remember. It's just a law of proportions. So notice here it is right here, the law of sines. It is on your formula sheet. It will be on your CSI formula sheet too. So here it is, A over the sine of A, B over the sine of B, all equals C over the sine of C. And you can just go ahead and use that to set up your formula sheet. So back to our review solutions. Okay, so here we're going to find side A. So to find side A, you just have to take this, multiply by the sine of 40, and here's your equation that you're going to go ahead and just put in your calculator. So to put this in your calculator, you're just going to go ahead and take your calculator. First, check to make sure that you're in the correct mode. So I go to my mode. I check to make sure I'm in degree mode. If I'm not, remember you can arrow down, highlight it, change it. Okay, and I'm just going to go ahead and type this in. So I got 100 times the sine of 40. And then divide by the sine of 12. Hit enter, and there's your answer of 309.164. So that's what side A would be. Now you can repeat that exact same process to find out what side C is going to be equal to. So to find side C, we just have to take the sine of 12 and multiply by it. So here would be our formula right here. So I got 100 times the sine of 28 divided by the sine of 12. Just go ahead and put that into your calculator. Just take your calc and type in 100 times the sine of 128. And then go ahead and divide that by the sine of 12. And then you've got your answer of 379.0122. So that's how you do number 16. You just use the law of sines. So same thing on 17. So on 17, we're going to use our law of sines. So on number 17, it says we got angle C is equal to 150 degrees. Side A equals 5, side C equals 20. So notice right here, you can set up your proportion. So we got the sine of A all over 5, sine of B all over B, and then we've got the sine of 150 all over 20. So now to find the sine of A, so notice you can just look at these two at the same time. And I'm going to multiply by 5. So I got the sine of A equals 5 times the sine of 150 all over 20. And remember, we're finding an angle here, so we have to use our sine inverse key. So to get A by itself, you're going to have to take the sine inverse of this answer right here. So then you just take your calculator, type that in exactly as you see it. So here's our calculator. We're going to type in, so hit second, type in sine inverse, and then just put in parentheses, we've got 5 times the sine of 150, and then divide by 20. And that angle comes out to be 7.18. So there's your angle A of 7.18. Now at this point right here, to actually find that other angle, you just go ahead and use the fact that you can subtract that from 180. So I'm going to take my two angles. So you're going to notice that my one angle was 150. My other angle is 7.18. So if we subtract those, I get 100 minus 150 minus 7.18. That gives me my angle B, which is 22.82. So now setting up that proportion. So here's my A proportion. I got the 5 over the sine of 7.18. All equals B times the sine of 22.82. So I'm going to multiply by this and put it in my calculator and find that answer. So putting this into your calculator, let me shut this off and slide my calculator out of the way so we can see it. So typing this in my calculator, I got 5. I've got times the sine of 22.8. And then divide by the sine of 7.18. Hit enter, and looks like that comes out to be 15.5. So here's my answers, 15.5 for that missing side B. And now you've solved your triangle. Okay, your next problem. Looks like we're on number 18. Let's see, did I skip over 18? Yeah, so looks like 18 isn't written on there, so let's just go ahead and write this one down. So number 18, so let me bring up a blank screen here. So number 18, 18 says that we have A equals 3, B equals 6, and then it says that angle C is going to equal 130 degrees. So the directions on this is just says find the area. So to find this area, you're just going to follow the formula sheet. So if you turn to your formula sheet, it says that the area formula is area equals 1/2 AB sine of C. So substituting that in, I get area equals, so I have 1/2 times 3 times 6 times the sine of 130. So that's just a matter of putting it into your calculator. So just take your calculator, and let's see if I can bring up my calculator here. So we'll go ahead and shut this off, and we'll just bring up the calculator. So on your calculator, just go ahead and type that in. So typing in this, we got 1/2 I got times, it looks like we got 3 times 6 times the sine of 130. Hit enter, and it looks like that comes out to be 6.894. So let's see if I can bring that back up. So that comes out to be, look like 6.894 for your answer. Okay, on this next problem, so we're taking a look at number 19. So number 19, it says that we have A equals 49, B equals 53, and C equals 38. It says use the law of cosines to find the remaining sides and angles of the triangle. So remember, you've got this all written down on your formula sheet if you need to refer to it. So go to your formula sheet. Here's your law of cosines. So your law of cosines just says the following. So we're using this side right here. Cosine of A equals B squared plus C squared minus A squared all over 2BC. Cosine of B equals A squared plus C squared minus B squared all over 2AC. And cosine of C equals A squared plus B squared minus C squared all over 2AB. So those are your formulas on your formula sheet. So we just come back to our problem and we just set it all up. So setting up this problem, so here is so cosine of A is B squared plus C squared minus A squared all over 2 times A. So here's A and B. So same thing for the next one. Just following your formulas. Cosine, just substitute that in. So that's 49 squared plus 38 squared minus 53 squared all over 2 times 49 times 38. And then same thing on cosine of C. So that's A squared, which would be 49 squared, plus B squared, which is 53 squared, minus C squared, which is 38 squared, all over 2 times 49 times 53. Now to put these into your calculator, you're going to use your cosine inverse key. Because remember, we're looking for an angle, so you want to put parentheses around it. So just type that into your calculator. You got A equals the cosine inverse of 53 squared plus 38 squared minus 49 squared all over 2 times 53 times 38. You're going to put that in your calculator. It should come out to be 62.63. So let's put this in our calculator, make sure that we're typing it in correctly. So notice you hit second, cosine inverse, and then you're going to make sure you want to put parentheses around your numerator and your denominator. So I'm going to need another set of parentheses here, so I'm going to type in 53 squared. I got plus 38 squared. I didn't get that 33 in there, so let's try that again. So 38 squared. Then I got minus 49 squared. So I'm going to need an end parenthesis, and then I'm going to be divided by, and I'm going to need a parenthesis around 2 times 53 times 38. And I'm going to need a parenthesis and then another parenthesis. I hit enter, and that comes out to be 62.63. So I'll repeat the same process with the other ones. Just make sure you're typing those in correctly. So notice you'll need parentheses. So I got cosine inverse, and I got parentheses, and then I'm going to need another parenthesis right here. So I got 49 squared, and then I got plus 38 squared minus 53 squared, end parenthesis, then divide, and then you'll need parentheses around 2 times 49 times 38. Then you'll need a parenthesis and then another parenthesis. Hit enter, and you'll get that 73.8. So again, repeat the same process with the last one. Find that last angle. So you're going to need to hit second cosine inverse. And let me scroll this up just a little bit so we can see it. So now you got parentheses around, you got 49 squared, and then we got plus 53 squared, then minus 38 squared, and parenthesis, and then divide, and we'll need parentheses around our denominator. So you got 2 times 49 times 53, parenthesis, and then another end parenthesis. Hit enter, and there's your last angle. Okay, on our next problem, on problem number 20, we're still using the law of cosines to find the remaining sides and angles of the triangle. You're going to notice that the information that they give us, we have angle C is going to be 29 degrees, side A is 100, and side B is equal to 300. So if you go to your formula sheet, you're going to notice that we're going to go ahead and find side C first. So if you look at your formula sheet, it will give you the formula for side C. So go into your formula sheet on the second page here. Here's the law of cosines. And so the formula I'm going to want to use is the C squared formula. So I've got C squared is going to equal A squared plus B squared minus 2AB cosine of C. Make that a little bit bigger so I can see it. Okay, now I'm going to go back to my review sheet and using that formula. So here's our formula right here. We're just going to go ahead and substitute it in. So remember, C squared is going to equal, so we have A squared plus our B squared, and then remember it's minus 2 times A times B, and then times the cosine of C. So that's the cosine of 29 degrees. Now when you put this into your calculator, we're just going to go ahead and take the square root of both sides. So that way we can just put it in our calculator all at once. So typing this into your calculator, I'm going to go ahead and bring up my calculator here, and we'll type this in. So into your calculator, I'm going to slide my calculator over. so we can see it a little bit better. So just go ahead and hit your square root key. Now we're going to type in 100, and we've got that squared plus, we've got 300 squared, and that's going to be minus 2 times 100 times 300, and times the cosine of 29 degrees. Okay, now I forgot to check to make sure that I am in degree mode. I've been using degree mode for the last couple of days, so I'm pretty sure I'm in degree mode, and I am. So I just checked to make sure that I'm in degree mode. Okay, now that I've done that, I'm just going to go ahead and hit enter, and that comes out to be 217.997. So that is my answer for side C, which is 218. Okay, now that I've found that matching side, now I can go ahead and use the law of sines to finish off this problem. So once you have a match, you can just go ahead and use your law of sines. So notice I just go ahead and match those up. So I've got sine A, and that's going to be all over 100. And then I've got sine B, that's all over 300. And I've got the sine of 29 degrees all over 218. So there's my law of sines. So now that I've done that, I can go ahead and find the sine of A by multiplying. So notice you can match up whichever proportions you want to match up. So all I'm going to do is just match up that proportion, multiply by that, and remember, since I am finding my angle, that would be the sine inverse of 100 times the sine of 29 degrees all over 218. So just take your calculator, and we'll go ahead and type that in. So this is what we're putting into our calculator. We've got the sine inverse. So hit second, and hit your sine inverse. Now type in 100 times the sine of 29. And that's going to be divided by 218. Hit enter, and there's your angle A, which is 12.85. Now I just need to go ahead and take my two angles. So I now have my two angles. I have A, which is at 12.85. I also have my other angle, which is which is given to me, which is 29 degrees. So now I'm just going to take these two and subtract it from 180 to find my third angle. So I take 180 minus 12.85 minus 29, and there's my angle B, which is 138.15 degrees. Number 21, the directions says use Heron's formula to find the area of the triangle. So it says that A is going to equal 4.1, side B is 6.8, and then side C is 5.5. So with Heron's formula, you can go ahead and go back to your formula sheet, and you're going to notice that Heron's area formula, it's just off to the side here, it has two parts to it. The first thing we have to do is we have to find this part right here, which is S is equal to A plus B plus C all divided by 2. And then once I find that, I can substitute it into my actual area formula. And the actual area formula says that I just take the square root of S, then times S minus A, times S minus B, times S minus C. Using that formula, go ahead and add those three numbers together. So here I've got my formula. It says that A plus B plus C all divided by 2 is going to give me my S's that I need to use for this formula right here. So that's my very first thing I'm going to do. So I'm going to go ahead and substitute in those numbers. So substituting in A, I got 4.1. And then I'm going to add my B, which is 6.8. Add my C, which is 5.5. And I'm going to divide by 2. Taking my calculator, adding those together and dividing by 2. I've got 4.1 plus 6.8 and plus 5.5. And since I didn't use my parentheses, I'm just going to hit equals and divide by 2. So that is my S value that I'm going to need inside my equation. So S is going to equal 8.2. Now substituting it into my formula. Here's my formula for my area. So here's my S value. So here's my 8.2. I got to take that 8.2 minus my A value, which is 4.1. I'm going to times that by 8.2 minus my B value, which is 6.8. And I'm going to take that times 8.2 minus 5.5, my C value. And I'm just going to go ahead and put that in my calculator to find that area. Substituting this into your calculator, go ahead and clear out my other. So I'm going to hit square root. I've got 8.2. And I need parentheses around 8.2 minus 4.1. And then parentheses around my 8.2 minus 6.8. And then parentheses around my 8.2 minus my 5.5. When I'm done, go ahead and hit enter, and your answer comes out to be 11.273136, and we'll just round that off to 11.27.